All right, like to get started. Do you guys have questions on homework? Guys, you guys doing your homework, or is it time to get a chicken run so you guys get your ass kicked?
Not today, tomorrow.
Are you doing your homework?
Yeah, I did it yesterday.
For today, last night's homework? Or the nights before's homework? Okay, you guys better watch it, okay?
I know, I can feel it.
Yeah, it's coming. Okay, you guys all right? Can I get started then?
Yeah.
Samantha, can I get started? Cliff, can I get started? Okay, so today there's going to be a lot of algebra, okay? A lot of algebra. A lot of symbols, so stay awake, okay? So today it's all about binomial expansion. Does everybody understand the term binomial expansion? Okay? So this is a binomial here. It's a binomial. It's got two terms in it. Binomial. Two terms. Okay? And the expansion means that if you've got some expression like this, x plus y cubed, you expand it out, this is what you get. This is what you get. So does everybody understand the first row? X plus y to the 0 equals 1. Everybody got that? Right? Anything raised to the 0th power is a 1. The next one is fairly obvious. X plus y squared is fairly obvious. Does everybody get that? Yeah? Mark, how would you do x plus y cubed? Well, how would you do it? Yeah, so you take this one and you times it by x plus y, wouldn't you? Okay, and imagine what you've got to do. You've got to kind of fold the stuff out. Okay? You guys with me on that? Beta, are you there? Okay, you fold it out and you would get this answer. Well, for x plus y cubed, that's not too bad. It's doable. And then look what happens if it's x plus y to the 4th. You'd have to take this one and then times it by x plus y. And then do the foiling again. And then do all that BS. Okay? Yeah? Yeah, so today's topic is binomial theorem, binomial expansion, and Pascal's triangle. So first we're going to start out with a good question. Do I start out with Pascal's triangle?
Wait, don't move it yet.
Oh. Do I start out with Pascal's triangle or do I start out with binomial theorem?
Binomial theorem.
Yeah, I start out with binomial theorem. Okay, guys, cut this down. Raj, come on. First of all, 7 minutes late.
There's a lot of traffic on Palm.
That's not my fault. You wake up early, man. Come on. I get here
There's
at
traffic no matter what on Palm.
That's because there are too many kids going to school. You guys should be staying home.
Oh, good idea.
Well, yeah, yesterday I was encouraging everybody to demonstrate by being at the Fremont Unified School District's board meeting. I want to shut the country down. I want all the workers to stop working. And then let the people in Wall Street feel the pain. You don't go to banks, you don't drive buses, you don't teach, you don't clean streets, you don't do gardening, you do nothing. Shut the country down. Let the bankers feel the pain. See how they make money off of us, man. We'll cut our salaries by 10%. Yeah, that would affect 38 kids in a class. Nasty stuff going on, man. I mean, 38 of your mission kids are, totally manageable. Imagine having 38 kids and some other school, like Kennedy, for example. It's hard. What? Got it already? Okay. Wow.
I got it.
Okay, so already got x to the 4 plus 8x cubed plus 24x squared plus 36x plus 16. Yeah? Okay?
I got 32x.
32x. 32x, not 36x? Yeah, 32. Okay, good. Okay, so did you guys feel the pain there? If you didn't, I mean, I can make this x plus 2 to the 8th. And then you'll start feeling the pain then. Okay? I mean, I can crank it up if you want. You guys okay on that? All right, so what we got to do is we got to find an alternative way of doing this.
So bring one and then show it off.
Share with only you and me. Awesome. Yeah. Okay, people, let's go through this, okay? What am I saying here? Okay, so if you take a look at it, it's very systematic. There's a pattern to it. It's a fairly easy pattern. So notice what's happening. X starts out at n, and n is this exponent, and it goes down by 1. Okay, goes down by 1 until there is no x. Well, when there is no x, remember it's equivalent to having an x to the 0. Right? X to the 0 is 1. Then when x is to the n, y is going to be to a 0. Okay? And then y is going to increase by 1. You guys got that? You guys got to turn that off, okay? Okay, it goes up all the way until the exponent of y becomes n. So if you notice what's happening is that the sum of the exponent of x and y is always equal to n. You guys see that? You guys see that? Okay? Get the pattern? No? Evelina, watch. If you add this and this, you get that. Okay? If you add this and this, you get that. Okay? So the exponents all add up to n. You start out at NC0. I'm assuming everybody understands what NC0 is, what NCR is. Right? Here's the definition of NCR. Okay, we've done this before. Okay, we've done this before. The key thing to really pay attention to is this statement here. That statement there. Okay? And you guys have it down, right? So I can continue explaining? Okay. What do I mean by this? What's the exponent of y here for the first term? Isn't that the first term? Isn't that the first term? What's the exponent of y in the second term? So isn't that the second term? So if you take a look at it, the term number is 1 more than the exponent of y. You guys with me on that? Okay. So the r plus 1th term is going to have y to the r, right? Because the term number is going to be 1 more than the exponent of y. You guys with me? Beta. Awesome. Okay, watch it. Okay, look. Let's go over it one more time. Hang on, let me just explain this one more time, then you can see. Okay. This is the first term, is it not? When I say this, I mean this guy here. Okay? This is the second term. You with me? This is the third term. Look at the relationship between this and the exponent of y. What do you conclude? The term number is 1 more than the exponent of y. So here is your r plus 1th term, because the exponent of y is r. So the term number must be r plus 1th. You guys okay on that? Yeah? Now what I want to do is I want to do this using the binomial theorem instead of that painful method that you guys just did and already got us the answer. Okay, instead of doing that. So if you compare this to this, you can see that x is x. What is y? 2. What is n? 4. So you're going to start plugging and chugging on these terms here. So you're going to go 4c0 x to the 4. The next one is going to be 4c1 x to the, you're going to reduce exponent of 4 by 1, exponent of x by 1, 3, and increase the y term by 1. 2 to the 1, because remember there's no y there, it's a 2. You guys with me on that? Are you guys with me? Yes? Next term then, tell me. 4c to the 2 squared. Next term. 4c3. You're reducing x by 1. X to the 1, 2 to the 3, 2 cubed. Okay? And the next term. 4c4, x to the 0, 2 to the 4th. Nice. Who's that? John? Yeah, nice. Good job. Next term. That's it? Everybody got that? Eli, did you get it in your sleep?
You tried that trick.
Did you get it in your sleep? Okay. Now what do you do? Now what do you do? This is not the end of the line.
Simplify.
You simplify. What's 4c0? 1. So you get x to the 4th. What's 4c1? 4. You guys know how to do this on your calculator and otherwise as well, right? Rash, you look kind of confused. You are confused, you're saying? Oh, you're not? Okay. 4c1 is 4. So we get 4x cubed. And what about the times 2? So that'd be an 8. Is everybody with me on this? So this is an 8. The next one's going to be 4c2. What's 4c2? 4 factorial over 2 factorial times 2 factorial. So that is 6. If you don't know how to do it, get your calculators out and be pounding that calculator, okay? So you're going to get 6x squared times a 4, right? What's 6 times 4? 24. Next one. 4c3. 4 and 2 cubed. 8 times 4. 32. So that'd be 32x. And then last one is 4c4. 1. X to the 0. 1. 2 to the 4. 16. Is that the answer already had? Yeah? So you can see you have either the other painful way of doing it or this painful way of doing it. So make a choice. Okay? They're all painful. I mean, they get even, I mean, this is not too bad doing it the original Algebra 1 painful way. But, you know, I can easily fix this by making this to the 40. And then you'll just kind of collapse, get a heart attack. You guys don't get heart attacks, right? You guys have. Good. Beta, do you even know what I'm talking about? Are you here, girl? You know what you're doing. Okay. So everybody all right on this? Wait. Oh, you're doing x plus 2 to the 40, Sharik? I don't want you to die yet, okay? Wait till Wednesday. Oh, okay. Okay. Different kind of problem. So I've kind of reproduced the box there just to keep it refreshed in your memory. Okay. So yeah, get this problem down and let's work on it, okay? Different kind of problem. This is a fairly common, I guess you guys don't do SAT 2Cs anymore, is that right? You are the last year that doesn't need to do it, or you're the first year that does not need to do it? Am I right? Oh, yeah, this used to be a fairly common SAT problem. Jenna,